Hello everyone. Today we are going to learn about nested structures. Nested structures means you can use a structure within another structure. So it is an advanced concept of this structures. So the nested structure is simply a structure that contains another structure as one of its members. So this helps us to organize related informations more efficiently. So for example, let me consider this one. We have the two structure which is called as an address and other one is called as a student. So the student who has an address as that is a student who has a member function members as the register number, name and CGPA. And within the student structure, you have another calling the another structure called as address. So where address is an another structure which could has a members as a city, street and pin code. So this parent structure is a student and we are calling the embedding this address into that parent structure's student. So we can consider the student who has an address instead of writing a separate variables for city and pin code inside the student structure. We can create an address structure and that include the student structures. So by using this methodology that improves the code readability and avoids the duplications of the structures. So the members of the nested structure are accessed using this multiple dot operators, such as, for example, if you are considering for this address city, if you are calling the city, this city could be there in the structure address and this address is there in the student. So we can access via this student dot address dot city. So by this way we can accessing the members of the functions which could be represented by means of this structures. So this nested structure are widely used in software applications where one object naturally contains another object. So this is an example. Here we can create the student a variable student structures. We can create a structure variable called as S. So if you are accessing the members in the student structure, you can use this S dot register number or S dot name or S dot CGPA. So this if you are calling the city, state and pin code means you can use this parent structure variable S dot addr dot city. So here this address is a structure. For this address we are creating the variable called address addr. So this could be specified over here within this parent structure. So in addition use this address, you can go with this. Here it is a variable which could be represented by as s dot addr dot ct. By this way you can call the nested structure member variable. So in this main function you are scanning this all the members with the help of this variables member functions various structure variable, and this could be used for displaying the output of this one. So if you are using this s.rg number means call this register number, prints the register number of the student, and this s.name means it representing this student name, and s.cgpa it is a CGPA of the student. And here if you are seeing closely look into that s.addr.ct means that the city is there in the structure called address addr, and this addr is embedded in the parent structure called as S structure variable. So like this way you can write this nested structures, and this is an example output for this event program. And the next topic we'll see about this self-referential structures. So where in the self-referential structure means, the self-referential structure is a structure that contains a pointer to the same type of data structures. At first, this may seem unusual, but it is extremely useful in implementing dynamic data structures. So, the self-referential data structure, which could be used in linked list type of this one, right? And here, this may be used for this. It is something like each node. It should be represented by means of each node representations, and this node, each one node is contains another data and the pointer. So this is something like a node representations, and this field is called as a data, and this field is called as a pointer, right? So these are all the node representations in general. So this pointer points the another data structures of the same data type. So that also contains, first one is data and other one is your pointers. So this pointer points in another data structure of same data type and creating a chain of the nodes. So this concept forms the foundations of the linked list, trees, graphs, stacks and queues. So without the self-referential structure, it would not be possible to implement these important data structures in C. So this example which is represented over here, we can creating this structure student, and it has a members as register number, name and CGPA, and this star next is a pointer which points to the another node that also contains this register number, name and CGPA for the student. So here we are passing this, we are creating the structure variable as S1 for the student structure and S1, S2 and S3. So these are all the three structure variable you are creating. So this S1 which consisting this values and S2 and S3. So at the last one we are representing that as null pointer, means that that is a pointer which will be used at this last, which cannot pointing any values. So initially it should be represented by means of null values. And if you are seeing this next step, S1 of next is equal to ampersand of S2. So this ampersand means it says the address of the next pointer. So this, if you are considering this as S1 and this as S2 and this as S3. So what it happened, this pointer of this S1 point to this S2 and this pointer of this S2 which points to this S3. So means that it is up, that's why we are saying that the address of S2 and S2 dot next is equal to ampersand of S3. And here what it happens means, we have to, there is no pointer that pointing this S1. So for that we have to create a point variable which is called as S. So this one is a struct student S star S. So this star S is equals to star, means that S is equals to ampersand of S1. So this S pointing this S1. So we have creating this linked list for this conceptions. And next one is we are printing this value. So for printing this values you are using this printf statement. Here you are using this star, it is a pointer, so you can use this arrow pointer over here for representing this values. So here why I am giving you S is equal to S dot next means, since it is a linked list, it has pointing one node is pointing in another node and that node is pointing in another node. So that's why we are supposed to giving over here it is S is equal to S of next. So here this loop still continues till the last node is null. So there is a last pointer is null, means there is no more node could be there. So that is the case of finding this last value, last linked list value, we just go with this while loop. So this is a simple programming for this self-referential structure. So this could give you the output of the self-referential structures. So it has printing this a student S1, S2. So this is S1 and this is S2 and this S3. So the first pointer is pointing this S1. So it has to print out the value of this S1 over here. And after that, this S1 pointer pointing to this S2. So it has to search in the second S2 record, and this pointing this S2, and this S2 pointer points next as S3. So this, the last one, it has to printing this S3, where this S3 pointer, it doesn't point anywhere because it is a last node. So it has to representing that as null values. So after printing this S3, it automatically terminates from the S3. So this is how the self-referential structure executes. So in summary, the structure provides several advantages of this programming. So they help organizing this related data into a single unit, and it improve the code reliability and simplify the program maintenance and accurately represent in maximum of this real world entities. They also make it easier to pass complex data to functions, and it is to be used mainly in this database applications and file handling and embedded systems and on operating systems. However, the structures also have some limitations. So what does that limitation means? They do not support this object-oriented features. So object-oriented features, you know that it is inheritance or data hiding and polymorphism. So the structures may not supporting this kind of this object-oriented features. So that is the main drawback of this structures. So here in generally the summarizing this today's lectures, we learned that the structure is an user-defined data type, is used for group variables of group different data types into a single unit. So we studied how to define the structures and create the structure variables and accessing those members using this dot operator. We also discussed the nested structures, which allow one structure to contain another structure, and self-referential structures, so which contains the pointers to the same structure type, and or it is essential for implementing this linked list and other dynamic data structures. So whenever we are having this dynamic data structures, we can go with the self-referential structures. So these are all the concepts in understanding the structures in fundamentals, because they form the basics of many advanced programming concepts that we'll study in the coming classes. Thank you.